All right, so today we're actually doing like adding numbers into stuff, okay? It's going to look more like normal math and not just naming this and that, all right? So we're talking about simplifying radicals. First thing we want to do is we want to remember what a prime number is. Do y'all remember at least the word prime number? Y'all learned that a long time ago probably, at least probably 4 or 5 years ago. Remember, a prime number is a number that can only be divided by 1 in itself. You don't have to write this down, but let's look at the factors of 6. What times what equals 6? 2 times 3, right? What else multiplies equals 6? 6 times 1. Okay? And that's all the factors of 6. So the fact is it's got more than one set of factors. More than just 1 times itself. So that means it is not a prime number. 6 is not prime. But what if I did 3? What times what equals 3? 1 times 3, right? Is there anything else? No. Because there's nothing else, that means that 3 is a prime number. And so when you look at all these numbers that we call prime numbers, every one of them, the only factors they have is 1 times itself. Okay? 5, 1 times 5. 13, 13 times 1, and so on. Okay? We're going to use these prime numbers, and they're going to help us to break down the radicals. Now, you want to take note that you need to memorize these first 6. You need to memorize these first 6. On the test, I will not be giving you the prime numbers. You need to have this. Okay? All right, let's do a reminder now. We've looked at primes. Now let's look at a reminder of square roots. Anyone make note that this is perfect squares? Do y'all remember square roots from Algebra 1? Hopefully. Okay, so remember, a perfect square is one that's got a radical. It's a square root that when you take the square root of it, comes out as a perfect number. Like, what's the square root of 64? Does anybody remember? 8. Okay. Square root of 64 is 8. And the way we remember that is what times itself equals 64? 8 times 8 is 64, right? Or another way we say that is 8 squared equals 64. We need to always remember that square root and squaring are opposites of each other. When you square a number, you're saying 8 times 8 basically is 64. Or if it's 10 squared, 10 times 10, or whatever it is. Okay. Now, and so you get to 64, and then when you take the square root of it, it's doing the opposite of it. Okay. Squaring it makes the number larger. Square rooting, it goes backward and brings it back down to the smaller number. All right. Square root of 16. What times itself equals 16? 4 times 4, so it's just going to be 4. Questions on that part? All right, at the bottom of your little foldable there, I've got 1 through 12 laid out on squares and square roots. We're going to work these because you need to, my goal is I want you to have these memorized at some point. Because it makes life so much easier if you can just remember, 12 squared, it's 144. 11 squared, 121, and so on. And being able to go back and forth. We're going to work on a lot of, because y'all are not going to use calculators a whole lot this year, we're going to work on doing a lot of just that old school math that you might have forgotten because you've been using calculators so much for the star testing and stuff. So let's run through these. 1 squared. What is 1 times 1? 1. Okay. 2 squared, or think of it as 2 times 2. 3 squared? 4 squared? 16. Y'all finish the rest of them. 5 squared, what do you get? 25. 6 squared? 36. 7 squared? 49. 8 squared?
64.
9 squared?
81.
10 squared? 100. 11 squared? 121. 12 squared? 144. Any questions with that? So next, let's do the square roots. Square root of 1 is what? 1. Square root of 4. 2. Square root of 9. 3. Finish the rest in your notes. All right, so let's finish this. Square root of 16.
4.
Square root of 25.
5.
Square root of 36.
6.
Square root of 49.
7.
Square root of 64.
8.
Square root of 81.
9.
Square root of 100.
10.
Square root of 121.
11.
Square root of 36.
12. 6.
6. I just see if y'all are paying attention. All right, square root of 144. 12. Okay. So like I said, you want to have those. We're going to work on those, probably do some warm-ups just to help practice those things, just so you can get really good at these. It's the goal. All right. So now we want to look at our first couple examples. When we take the square root of a perfect square and we get, like, say we did square root of 64 and we got 8, that was simplifying it. That was breaking it down, right? It was perfect, though, so it just came out to be a whole number. If you notice square root of 75, does that fit any of our perfect squares we did there? No. Because you have square root of 64, then you jump to square root of 81. 75's between it, so it's not perfect. Okay? So when it's not a perfect square, if you were to put it in a calculator to give you a decimal, we're not working with decimals. We're going to keep it in what's called a simplified radical form. So we want to break down the radical and make it a little bit smaller number, and I guess it easier to digest. And then that'll be your answers. That's the goal of what we're doing here. So let's break this down. And the way we do this is we want to take our prime numbers, 2, 3, 5, 7, 11, and 13. Remember those first 6? I always recommend you write them just somewhere, at the top of your homework or whatever, so that they're just right there in front of you all the time. When you get your test on Friday, that's the first thing I would do. When you get the test, write down your 6 prime numbers. That way they're right there in front of you. You don't forget them whenever you start maybe struggling or anything. And what we're going to do is called the factor tree. Y'all remember doing factor trees? Okay. And what we're going to do is we're going to factor out and bring out all the prime numbers that is in that number. So you start out by saying, hey, we got square root of 75. And I need to ask myself, which one of those prime numbers will divide into 75? Okay. A couple of things to remember is if it's an even number. And what is an even number? 2, 4, 6. So it ends in a number 0, 2, 4, 6, or 8, right? If it's an even number, you can always divide it by 2. Okay, so always keep that in mind. Like example 2 is an even number, ends with 0. You can always divide that one by 2 if you can't remember any of the other ones. If it ends in a 5 or a 0, we can always divide it by 5. Okay, so those are a couple tricks just to remember that. So this one ends in 5, so I know that I can divide it by 5. So I'm going to put my prime number on the left, and I'm going to circle it. Always put your prime on the left, and then circle it. Now what I need to do is 75 divided by 5 to see what the other side of that tree is going to be. You might have to do some old school dividing. You probably haven't done this in a long time. But we're going to do 75 divided by 5. Because remember, you will not have calculators for this test, so you need to remember how to do this. So how many times will 5 go into 7? Once. 1 times 5 is 5. So we subtract 5. 7 minus 5? 2. And then bring the 5 down. How many times will 5 go into 25? 5. Minus 25. And we have 0. So what's our answer? 15, right? 75 divided by 5 is 15. So we can put the 15 over here. Is 15 a prime number? No. So what we need to do then is break it down. What prime number goes into 15? 5. And what do we do with our prime numbers? Circle them. 15 divided by 5? 3. Is 3 prime?
Yes.
Yes. Once you get to where every branch has a prime number at the end of it, then you're finished with breaking down the tree. So we stop there, okay? Because we can't break down 3 with any other prime number. Does that make sense? Just break down the tree till you have prime numbers and you circled them all at the end. Next. So after this, so if you want to make notes, so we're going to factor out prime numbers. That's our first step. Second step is we're going to put all primes under the radical. So the radical is, remember, it's just your little radical sign. Remember that it's not a normal division. You have to have this little leg kicking out right there. Okay? We're talking about radicals. Division is just the 90 degree, the two lines like this. Radicals are got the little kicker. Now I want to list out all the prime numbers I circled under there, but keep the same numbers together. For example, put all the 2's together, all the 3's, all the 5's, and so on. So how many 3's do I have? 1, 3. So just write it. How many 5's do I have? 2. Put multiplication symbols between each of these because they're multiplying. Because remember, it's a factor tree. And for this class especially, and basically for the rest of your math career in high school, don't use X as a multiplication symbol. Because when you're doing algebra and you have X as a letter, you'll get confused with what is X and what's a multiplication. So always just put the dot for your multiplication symbol. Now the next step we want to do, third step, is circle pairs. Circle your pairs. And if you ever notice, sometimes when I write stuff out, I don't use correct grammar. I just try to keep it as short as possible. That's on purpose. If you go to college, you'll get really good at that. Just trying to keep the notes as simple as possible. All right. So do we have any pairs in there? Like any groups of 2 of the same number?
Yes.
Which ones? 5's. So let's circle the 5's. And you're going to drop them down. So now I need to draw another radical. So I'm going to give you just a cheesy little way of helping you remember this. Think of the radical itself as like a house. In it I have single numbers and I have pairs of numbers. Think of it as the pair numbers, they get married. And when they get married, they leave the house. Okay? The single numbers are going to stay in the house. They're not married yet. They don't leave the house. Okay? Think of it, I don't know. However it works, they're single, like single people typically a lot of times stay with their parents till they get married, and then they, get married, move in. But when 2 people get married, what happens is they become one together. All right? You're now together as one unit, right? So whenever those 2 5's got married, they leave the house as 1 5. They're one. Okay? Their identity is one in each other. Now, what we do is we take the rest of our single numbers and we put them all inside. And we only have one single number, and it's just 1 3. And then that's going to be our answer, 5 square root 3. Once you get all the pairs, all the married ones, and they leave, they go outside. Then when you have all the singles inside, And if you had multiple, so say you had like a 3 and a 7 underneath, what you would do is multiply those out. So if it's 3 times 7, you'd say 21. But since it's just 1 and 1, there's nothing to multiply there, there's nothing to multiply out here. So it's just 5 square root of 3. So your last step there, I'll put pairs outside and singles inside. All right, let's quickly work number 2. So is this a perfect square? 20? Does that work out perfectly? No, it's not a perfect square. So that means we got to break it down with the tree. Real quick, look at your homework. See if you have any perfect squares.
Yes, 36.
So what number is that?
Number 8.
Number 8 is square root of 36. That's a perfect square. What's the square root of 36?
6.
6. That's your answer for number 8, 6. So put 6 and box it in. Now we'll say on your homework, if you want to do it on another, like do all the work on another sheet of paper, that's totally fine. Just make sure you staple this on the back.
When we do this, like for number 8 on 36, when you hit box it in, we need to put 6 and box it in, or you want us to do that?
Yeah, no, you don't have to do the factor tree or nothing. If it's a perfect square, just put the answer.
That's fine.
Yeah. All right, so number 2. This one's not perfect, so let's break it down. I'm going to go a little quicker through this. It's got a 0 on the end, so we can divide it by 5. What do I do with my primes? Circle them. 20 divided by 5? 4. Let's break 4 down. It's not a prime number. What numbers will go into 4? 2. And 4 divided by 2 is 2. So it's another one. Am I finished with the factor tree? Well, with just the tree part of it. Can I break it down anymore? No. We're finished there. So now we got to build the house. And we put all of our prime numbers in there. Tell me what to write under here. So 5 times what? Times 2. Remember, always keep your same numbers grouped together so you can easily find your pairs. Do we have any pairs?
Yes.
Which ones?
2.
The 2s. So what do the pairs do?
Stay outside.
They leave the house, right? So they leave the house as how many? As 1. So those 2 2s become what? Just a single 2 outside though. And then what goes inside the box? 5. If you would have had nothing but pairs, you would have just had, they would have just all gone outside and nothing in the box. Okay?
So then do you have to put that thing, or you can put the whatever the number is?
If nothing goes back in the radical, don't put the radical. Just drop it. Okay? That means it's a perfect square. So some of them are large perfect squares. Last step is to simplify. So what goes into 25? 125, I'm sorry? 5. How many times? 25. Remember, you come over here. 125 divided by 5. 5 goes into 12 2 times. Subtract it out, get 2, and then bring your 5 down. 5 goes into 25 5 times. Okay, so 25. Then 5 will go in it again with another 5. So basically, he's got 3 5s that need to go under the radical. 5 times 5 times 5. Circle your pairs, okay? Remember, a pair has how many in it? 2. So only circle 2 of them. Okay. A lot of people like to circle all 3 of the 5s. Only circle 2 of them. And then what happens to the pairs? They go outside as 1. So those two fives become just one single, well, one five together, and then the single five that's still inside just stays inside. So you should have got 5 square root 5. So we got square root of 192. Remember our primes are 2, 3, what else? 5, 7,
11, 13.
11, and 13. Okay, that's our first 6 that we need to have memorized. Which one of those will go into 192? 2. How do we know 2 will? You're correct, but how do we know? Because it ends with a 2. It's an even number, right? So we know 2 will go into 192. So let's go off to the side and do our long division. How many times will 2 go into 19? 9 times. So 9 times 2 is 18. And that's 1. How many times will 2 go into 12? 6. Okay. So we got 96. All right. What will go into 96? Which one? 2. It's an even number, so we know 2 will go into it. Brady, 96 divided by 2?
96 divided by 2 is.
Good. 48. Okay. Class, what's another one number going to 48 now? 2. Mandy, 48 divided by 2? 24. Next one. What goes into 24? 2. Luis, 24 divided by 2? 12. What's another one, class? What goes into 12? 2. And got 6 go into it. And then 2 times 3. All right, so it's a lot of 2s. I kind of call it like you're 2ing it to death, okay? Just attacking it with 2s, and that's fine, as long as you get all the way to the very end. So now what we need to do is set up our radical. And how many 2s do we have? 6 of them. So let's put them all in there. And then we have 1, 3. Remember, you want to put all of them on there. And then we circle all of our pairs. How many is in a pair? 2. So all of our pairs of 2s. What happens to the pairs?
They go outside, or they turn into 1.
Yeah, they get married, turn into 1, and go outside. Okay? Man, we got 3 weddings today. It's a great day, right? Got a lot going on. So all 3 of those are going outside. And they become 1, right? So that first set of 2s becomes a single 2. The next one, a 2. And the third one, a 2. And what's left inside? The 3. He is the 7th wheel, right? All right, the outside, we got to simplify it. We got 2 times 2 times 2. What is that? 8. Because 2 times 2 is 4, times 2 is 8. And then inside, there's nothing to simplify, so it's just 3. And that's it. Yeah, I'll go through this one pretty quick. So let's do 5 goes into it 45 times. 5 and 9. 3 and 3. Put them all under the radical. 3 times 3 times 5 times 5. Circle your pairs to get married. They're going to leave the house. 3 times 5. Is there anything left in the house? Nope. So we don't even need to draw it. So we just 15. It's a perfect square. And that's it. Nobody's left out. Everybody got married today.